There. Okay, this is the math part. It begins. The setup has ended. Now we're in math class. How many triangles do you see? Well, obviously, the pyramid face is one triangle. We all saw that. And we saw really that when you're there, you could see two sides at the same time. That's not hard. And it's got 4 triangles. Okay, so we see that triangle. Some of you may see that there's another triangle here. Okay, it's interesting. What else do you see? Everything is here before I break it down. All right, let's go. First of all, D. You cut the pyramid in half visually to create a right triangle and one of the legs of a new bigger triangle. Okay, so let's look at this dotted line here. Isn't this the height of the pyramid? Isn't this what we're after? So we visually split this other triangle that we can't do much with because it's an isosceles triangle. We need a right triangle to do a lot of things in math. Well, not everything's a right triangle. You can make it a right triangle. You can make it a right triangle, which is what he did mentally. Boom. Line straight down the middle, right triangle. And this becomes one of the legs of a new triangle. And if you follow this little dotted line here and this little dotted line here, you will see the new triangle that perhaps you did not see before, but Thales saw. Use sunlight. This is a part I'm not saying many of you caught on. You saw the sun. Use sunlight and shadows it creates to create the hypotenuse of our new right triangle. Boom. That is our new right triangle. And you're using sunlight, which is available to all, clearly in sight, shadows clearly in sight, but he saw them differently. He saw them as lines and legs of a triangle. Okay? So that was C. You could see the shadow is part of it, and then the base is part. We're going to use part of this base and part of this shadow to create a full length of our new bigger triangle. You made this problem bigger, Mr. E, not smaller. Boy, you're an idiot, Mr. E. Okay, well, with just a stick. Oops, I did that too fast. Hold on. Oh, wait, yay. With just a stick and a shadow, created a mini version of this new triangle. He went a little bit further on. He used his stick, put it on the ground. At the same time now, so the sun would create the same angle and the same type of shadow. You see this? This is a little mini version, not of the pyramid, but of this right triangle. Just a stick. Okay, why would he do this? Well, he can measure the small triangle, can't he? And then you can compare 2 similar triangles. And you could do what a copier does. Just enlarge or shrink the numbers by a number. A copier, it has a simple button, 2 times as big. The problem is we don't know how many times as big is our little triangle than this triangle. Once we get that number, just one calculation we have to do and boom, we know the height. Compare the height of this stick to this. If we know the number, if we know how many times it's being enlarged, is it 10, is it 20, is it 30? If we know that, we know it all. Okay. Hey, chances are not going to be an even number either. It's going to be like, it's going to have a decimal. All right, here we go. Question. Why can we be sure that similar triangles use the same ratios? That is a question for geometry class when we just study these triangles. How do we prove that that is so? That if you have similar triangles, they basically follow the same proportions, the same rules, and you can use one to know the size of the other. How do we prove that? That's a theorem. All right, that's what you should be asking yourself. All right, let's review the facts of the case. The sun is shining or was shining. Similar triangles have different widths, heights and widths. Here's numbers where you want to write it down. So get a pencil, please, and paper, because you're going to have to do some number crunching now. Now these numbers mean something. The base of the pyramid is 230 meters long. I'm writing that down. You are 1.4 meters high. You measured your shadow and it's 1.22 meters long. The shadow of the pyramid at that same exact time was 12.03 meters. Okay, if you want to hit pause, see how you can use these numbers to get the height of the pyramid, please hit pause. Okay, I'm going to go on and show you how to do it. All right. The first thing we must deduce is the critical number. One piece of information we need. Usually in problems, there's one piece of information that's critical, that makes or breaks the case, let's say. All right, and in our case, is we have to find out the leg of our newly created, the length of one of the legs of our new triangle, the big one. Okay, how do we do that? Well, let's look at the picture real quick. We realize this is the leg I'm talking about right here. And we want part of this pyramid here. We want to use the base. And then we want to use the shadow, and we want this whole thing. Okay? But we don't want just simply the number of the base of the pyramid. Okay? We want it in half. Okay? Knowing that, it becomes real simple. We have the base of the pyramid. We have the numbers, 230.4 actually. Should write 0.4. And we got to divide it by 2. Go ahead and do that. I'm going to pause and wait. 230.4 divided by 2. Should be able to do that in your head, or if not, a calculator. Okay, did you get 115.2? Congratulations. That is the length of one of the legs of our triangle, right triangle. If we have any other information, the second one, we can solve the entire triangle. That's the beauty of triangles. They're just two pieces of information. You can solve the whole triangle. We don't know the angle of the sun. If we had that, we could use it. Gosh, what else could we do? Oh, well, we have to do this other part. Just because we have half the base, that's not the length of our leg, is it? We have to add the shadow length. So 115.2 plus 12.03 gives us what number? Again, I'll pause, okay? Should be able to add those fairly easily, and that will give us the length of the leg. Sorry, I got ahead of myself. What number did you get? 127.23. I'm gonna write that down. 127.23. We're gonna need that. That's the, what is that? That is the length of base of the big triangle. Now this is how you want to set it up. Stick height. This is really a fraction without the little bar, if you will. So look at this as a fraction. Stick height is on top, 1.44. The stick shadow is 1.22. We have it set up as a fraction or as a ratio. Remember we talk of ratios, 2 to 1, making rice. You need 2 cups to 1. Well, what good is that? Well, this is a ratio. Okay, it just tells you when the stick is 1.44 meters high, your shadow will be 1.22 meters long. That is the relationship between those two numbers. They're close, but they're not 1 to 1. So if I grew the stick height to 2 feet, the stick shadow would grow as well, but not quite as much to 2 feet. It'd probably be like 1.7 or something. But we want to know exactly what that relationship is. And how do you do that? Well, it's a fraction, I said. How do you convert a fraction to an exact decimal? You divide. So if you divide these two numbers, 1.4 divided by 1.22, you will get the ratio number. And you can use that. But that's not the only way. Let's continue. There's another fraction over here, and that is the pyramid height, and then the pyramid shadow, the base, okay? So we know what the pyramid shadow is because we deduced that number pretty quickly, 127.23 meters. Because these are two similar triangles, we could literally put the ratios next to each other. They should equal each other. So there's an invisible equal sign here. Couldn't really do it in Excel or PowerPoint, but I kind of put it here. 1.44 divided by 1.22 equals what? That is your ratio number. That's one way to do it. The other way is if there's an equal sign here and these are two fractions, you should be able to use cross multiplication. That's why why do I have 127.23 times 1.44? Because you cross multiply these two numbers. Okay, by the way, that's the ratio, the exact ratio. But when you cross multiply those two numbers, it gives you a number that you would put at the top here. What number is that? I thought I had it there. Well, 178.2.12. That's what number goes up top here. So you know 1.22 times some number is supposed to give you 178.12. That's the way cross multiplication works. When you have equivalent fractions, okay, when you multiply this number by this number and you put it up top, you should be able to get that number by multiplying this bottom number by this top number. It's just fraction magic. Equivalent fractions work that way. So all we really have to do is multiply these two numbers, which we did to get 178.12, and then divide it by 1.22, and that will tell us what this number is. That will tell us what number times 1.22 gives us 178. Right? If multiplying two numbers gives us an answer, then if we have the answer, we divide to get the multiplication numbers, the factors, if you will. So go ahead and do that now. 178.12 divided by 1.22, that will give us the final answer, and that will tell us the height of the pyramid. All right, I will pause here. Answer, 146 meters. The Great Pyramid in Egypt is 146 meters tall. Do you want to learn more math from Thales or Pythagoras? Please join me for another lesson next week. In conclusion, sometimes the sun, your shadow, and a stick are all you need. Are you clever enough to think of using the resources around you to get what you need? So you could be like Queen Bee and do what no one else can, or walk the line like Johnny Cash did. All right, this is Mr. E, over and out. All right.